Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.5, Problem 5. So this is Problem 5 from Section 2.5. It says find the inverse of the matrix. And they give you a larger matrix than this one. It has 3 rows. So the top row is 1, 3, 3. The middle row is 1, 4, 3. And the bottom row is 1, 3, 4. So we're going to use the same process as we've used in the other problems. In this section, we're going to make a double matrix, essentially, and put the matrix that they give us as the left half of the double matrix in an identity matrix the same size as the right half. So we're going to start with the matrix that they gave us. So it's going to be 1, 3, 3 as the top row, 1, 4, 3 as the middle row, and 1, 3, 4 as the bottom row. And right next to that, the right half of our double matrix is going to be in an identity matrix the same size. So in other words, identity matrix with 3 rows. So the top row will be 1, 0, 0. The middle row 0, 1, 0. And the bottom row 0, 0, 1. So here's a big wide matrix that we're going to have to solve the left half of. And what's going to happen is when we solve that left half, the right half of this double matrix will turn into the inverse. So again, this big matrix we're solving, the top row is 1, 3, 3, 1, 0, 0. The middle row is 1, 4, 3, 0, 1, 0. And the bottom row is 1, 3, 4, 0, 0, 1. It's a big matrix. So to start, what we have to do is take the value in the upper leftmost position and turn it into a 1. Now, it already is a 1, so that's good. That saves us a little bit of work. The next thing we have to do is the rest of that leftmost column has to be turned into zeros. So right now they're 1s. We have to do some work, make them zeros. So as I set up the next matrix, the top row can stay. I don't want to change anything. It has a 1 where it needs to be. I don't want to change that, so the top row will stay 1, 3, 3, 1, 0, 0. So now as I move into the second row, the value in that first column of the second row is got to be changed into a 0. Right now it's a positive 1. So next to the second row of my new matrix, I'm going to write one of those equations. It's going to be row 2 equals some stuff plus the old row 2. Now again, I start this equation with row 2 because that's the row I'm making a 0 in. And I end the equation with row 2 because it should begin and end with the same row. Now what I call stuff is going to be the row with the pivot position, which is row 1. And it's going to be times the same number opposite sign as what's being turned into a 0. So times negative 1. We're turning a positive 1 into a 0, so same number opposite sign is negative 1. So the equation I'm going to use to make my new row 2 is row 2 equals negative 1 times row 1 plus the old row 2. Now as I do that, the first column, negative 1 times row 1 will be negative 1 times 1. That'll make a minus 1. I'm going to add that value to row 2. So minus 1, positive 1 is 0. Next, negative 1 times row 1 is negative 1 times 3. That'll make a negative 3. And I'm going to add that to row 2. So negative 3 plus positive 4 is 1. Next, negative 1 times row 1 is negative 1 times 3. That'll make a negative 3. I'm going to add to positive 3. So negative 3 plus positive 3 is 0. Next, and I keep going through the whole big double matrix, negative 1 times row 1 is negative 1 times 1. That's minus 1. Plus row 2. So minus 1 plus row 2 is minus 1 plus 0. That's minus 1. And next, minus 1 times row 1 is negative 1 times 0. That's 0. Plus row 2. So I'm going to have 0 plus 1 is 1. And finally, one more. I'm going to do negative 1 times row 1 is negative 1 times 0. That's 0. Plus row 2. So I'm going to do 0 plus 0, and that's 0. So that finishes row 2. So my new row 2 is 0, 1, 0, negative 1, positive 1, 0. So now I need to make a new row 3, so it'll have a 0 in its leftmost position. So next to row 3 of my new matrix, I'm going to write a little equation. It'll be row 3 equals some stuff plus the old row 3. Now again, I begin this equation with row 3 because that's the row I'm making the 0 in. And I end it with row 3 because the equation should begin and end with the same row. Now what I called stuff is going to be the row with the pivot position, which in this step is row 1. And it's going to be times the same number but opposite sign is what's becoming a 0. I'm turning a positive 1 into a 0, so the same number opposite sign is negative 1. So the equation I'm going to use to make my new bottom row is row 3 equals negative 1 times row 1 plus the old row 3. And again, I'm going to apply that to every value of row 3 to make a whole new row 3. So when we begin, negative 1 times row 1 is negative 1 times 1. That's minus 1 plus row 3. So I'm going to do minus 1 plus positive 1 is 0, and that's what I wanted. But next, negative 1 times row 1 is negative 1 times 3. That's minus 3. Plus row 3. So I'm going to have minus 3 plus positive 3 is 0. And then the next position, negative 1 times row 1 is negative 1 times 3. That's going to make a minus 3 again. And you're going to add that to row 3. So I'm going to do minus 3 plus positive 4. So that's 1. Next, negative 1 times row 1 is negative 1 times 1. That's minus 1. Plus row 3. So I'm going to do minus 1 plus 0 is minus 1. Next, minus 1 times row 1 is minus 1 times 0. That's 0. Plus row 3, so I'm going to do 0 plus 0. And finally, negative 1 times row 1 is negative 1 times 0. That's 0. Plus row 3, so I'm going to do 0 plus 1 is 1. So that's my new bottom row. 0, 0, 1, negative 1, 0, positive 1. So a lot of extra 1s and 0s kind of showed up on their own with this, which is very convenient. So we completed the left column. We got the 1 first, which we had anyway, and then we made the 0. So now I'm going to go over one column to the left, to the right, and get the 1 where it goes first, which is in the middle of that second column. Now it already is a 1. So what I need to do is 0 out the rest of the second column. Now, one of the values is already a 0. So what I need to do with this second column really is just turn the 3 in the top position into a 0, and then the second column will be done too. So let me start another matrix. And what I'm going to do is make a 0 in row 1. So next to row 1 of my new matrix, I'm going to write one of those equations. It's going to be row 1 equals some stuff plus the old row 1. And again, I begin this equation with row 1 because that's the row I'm making the 0 in. And I end it with row 1 because it should begin and end with the same row. Now, what I left as just stuff initially is going to be the row with the pivot position, which in this step is row 2. That's the row with the pivot position. Times the same number but opposite sign is what's becoming a 0. I'm turning a positive 3 into a 0, so same number opposite sign is negative 3. So the equation I'm going to use to make my new row 1 is row 1 equals negative 3 times row 2 plus the old row 1. And I'm going to apply that equation to every value of row 1 and make a whole new row 1. So as I begin, negative 3 times row 2 is negative 3 times 0, which is 0, plus row 1. So I'm going to have 0 plus 1 is 1. Next, I'm going to do negative 3 times row 2. That's negative 3 times 1. That's negative 3 plus row 1. So negative 3 plus positive 3 is 0. And next, I'm going to do negative 3 times row 2 is negative 3 times 0, which is 0, plus row 1. So I'm going to have 0 plus 3 is 3. And then next, I'm going to do negative 3 times row 2. Negative 3 times negative 1 is positive 3 plus row 1. So positive 3 plus positive 1 is positive 4. And then next, negative 3 times row 2 is negative 3 times 1. That's negative 3 plus row 1. So negative 3 plus 0 is negative 3. And then finally, negative 3 times row 2 is negative 3 times 0, which is 0, plus row 1. So 0 plus 0 is 0. So that finishes my top row. My new top row is 1, 0, 3, 4, negative 3, 0. And now the other two rows can stay the same. I don't want the middle row to change. It has a 1 where it should be, so my middle row will be 0, 1, 0, negative 1, positive 1, 0. And the bottom row, I want to have a 0 in that second column, and I do, so that doesn't need to change. So 0, 0, 1, negative 1, 0, 1. So the last thing I need to do, really, is 0 to 3 in the upper right of the left half matrix. Ordinarily, what I'd have to do is get a 1 in that bottom column, which would take some work, that rightmost column of the left-hand matrix. It already is a 1. And then one of the values in that third column over in the leftmost matrix is already a 0. All I really have to do is make that 3 in the top position of the third column over of the left matrix into a 0. So let me just come to the right a little bit here, and I'll make a new matrix. And I'm going to make a new top row. So on my new matrix, next to row 1, I'm going to write one of my little equations. It's going to be row 1 equals some stuff plus the old row 1. Now again, I start that equation with row 1 because that's the row I'm making the 0 in. And I end it with row 1 because the equation should begin and end with the same row. And initially, I just leave a blank spot and I call it stuff. And then I fill it in. So the stuff should be the row with the pivot position. Now in this step, the row with the pivot position is row 3. And it's going to be multiplied times the same number but opposite sign as what's becoming a 0. So what's becoming a 0 is a positive 3. So same number, opposite sign is a negative 3. And my equation to make my new top row is row 1 equals negative 3 times row 3 plus the old row 1. And that'll make a new top row for me. And that should finish the problem off. So as I go through the whole row 1, negative 3 times row 3 is negative 3 times 0, which is 0, plus row 1. So I'm going to have 0 plus 1. That's 1. Then the next value over, I'm going to do negative 3 times row 3. I have negative 3 times 0. That's 0. Plus row 1. So I have 0 plus 0. That's 0. And then the next position over, I'm going to have negative 3 times row 3 will be negative 3 times 1. That's negative 3. Plus row 1. So negative 3 plus positive 3 is 0. And then the next one over, negative 3 times row 3 is negative 3 times negative 1, which is positive 3. And then positive 3 plus row 1, so I'm going to do positive 3 plus positive 4 is 7. And then after that, I'm going to do negative 3 times row 3 is negative 3 times 0. So that's 0. Plus row 1. So I'm going to do 0 plus negative 3 is negative 3. And finally, one last position for my new top row. Negative 3 times row 3 is negative 3 times 1. That's negative 3. Plus row 1. So I'm going to do negative 3 plus 0 is negative 3. And that finishes the top row. So the top row of my new matrix is 1, 0, 0, 7, negative 3, negative 3. Now the middle row is good the way it is, so I can just copy it in. It's 0, 1, 0, negative 1, positive 1, 0. And the bottom row of the matrix is good the way it is, so I can just copy that in. It's going to be 0, 0, 1, negative 1, 0, positive 1. So at this point, the left half of our double matrix is an identity matrix. So 1s and 0s are all in the correct positions. And the matrix that's the right half of my double matrix is the inverse of the matrix that was originally given in the problem. So I can write A inverse, and again, it looks like it's written a to the negative 1 power, but it's really read A inverse, equals, and it equals the right half of my double matrix, which is 7, negative 3, negative 3 as the top row. And then negative 1, positive 1, 0 is the middle row. And then negative 1, 0, 1 is the bottom row. And that's the inverse of the original matrix that was given.